Welcome to this video example. Today we're going to be looking at how to solve systems of linear equations using Gaussian elimination. So let's take a look at how this works. Let's look at a simple system. Here we have three equations and three unknowns. And so what we do is, just like in class, what we're going to do is we're going to convert this into a nice augmented matrix in the usual way. So just to remind you how that goes, what we do is we store the coefficients for x in the first column. And so just pulling those out, I just see these numbers. Then we go to the second column and we collect the coefficients of the second variable, y in this case, and I have these, -6, -10, and 6. And then the z coefficients go in this third column, -4, -9, and 5. Now this is the augmented matrix, so after we take care of storing the coefficients here, on the other side of this dotted line, we're going to put whatever we see on the other side of the equal signs. So here we get these. So that's what we have very nicely. And I'm going to refer to these later, so I'm going to just identify these rows as row 1, row 2, and row 3, denoting them like that. So what I'm going to do here is I'm going to apply the Gaussian elimination techniques to try and solve the system, and what that would mean for us would be to see if I can figure out what x and y and z are. So as a first step in this process, what I like to do is I like to see if I can take the first row and use multiples of that row added to these others, and to see if I can eliminate, that is, make zero, these numbers that happen below this non-zero number up here. So that's what I'm going to do. Now if I do that, I see pretty easily that if I take the first row, multiply it by -2, and add it to the second row, that will produce a new row 2. And if I do that, that's going to cause this, whatever's left here, will be a 0. We'll see that in a second. I'm also going to do the same trick on the third row, so I'm going to try and get rid of this -1 here and make it a 0. And to do that, I just have to take the first row and add it to the third row to create a new third row. So let's do that and see what we get. So let's see. Nothing happens to the first row, so that just stays the same. I'm not replacing that one at all. And so I'm just going to keep that there. And we'll see what happens to these other two rows. So -2 times this first row up here, that'll give me a -2 in the times 1, plus 2 gives me a 0, as expected. Now I'll take -2 times this 6, this -6. -2 times -6 is +12. Added to -10 gives me 2. Then I'll take -2 times -4 here. That gives me 8, and that will add to this -9 here. Then I'll have a -1. And finally, I'll have -2 times this -5. That gives me +10. Plus this -4, that gives me +6. Okay. Now I'll just add the row 1 and row 2 and write down the result in the third position. And I see that just adding, that's easy to see. It's going to give me a 0 here. This -6 plus that 6 gives me a 0 also. That's very nice. And then -4 plus 5 gives me a 1. And finally, -5 plus 3 is -2. Okay. Well, that 0 here was really nice, because now I can just look at this bottom row, this new row 3, and I can see that it corresponds to the equation z equals -2. So I already can see part of the solution to this system of equations. It's going to have the z coordinate be -2. So what we're going to do next is we're going to see if we can now create zeros in these upper positions here, the ones that are above the diagonal. And if we can, we ought to be able to figure out what x and y are as well. So let's see how that works. Okay, we're on a new page here. So here's our augmented matrix written again. Now we have some room to do some more work. So what I'm going to do is I'm going to now try to put zeros in this third column by taking multiples of this third row and adding them back to these. So I see the first thing I might want to do is to take, let's see, if I take row 3 and add it to row 2, I can get a new row 2, and it should have a 0 in this position. Similarly, if I take 4 times row 3 and now add it to row 1, I'll get a new row 1, and it'll have a 0 in this position. So let's go ahead and do that. Let's see. So nothing whatsoever is going to change in the third row. It's already in as nice a form as we could want. But these other guys could change. So let's see. If I take row 3 plus row 2, I can just add those and put those in. 0 plus 2 is going to give me a 2 here. 0 plus 0, of course, gives me 0 there. I see I'm going to have a 0 here. And then 6 plus minus 2 is 4. Very nice. And now I will take 4 times this third row and add it to the first row. So again, the zeros here, when they get multiplied by 4, nothing happens. So 0 times this, 4 times this 0 is just going to give me this, and added to this 1 just gives me this 1 back. Nothing's going to happen to that minus 6 either. And now I take 4 times 1 and add it to this, and I'm going to get a 0. And finally, I have to keep track of what happens in the last column here. So I take 4 times this minus 2, that's negative 8, plus this negative 5 is negative 13. Okay. Well, now I see I could get a 1 in the second row if I just take this second row here and multiply it by half. So the next step, I'm going to take 1/2 times row 2 and make a new row 2. Okay, that's easy. Now let's take a look at this other row up here, and what I'd like to do is 0 at this position. So if I take my second row here as it is, multiply it by 3 and add it to the first row, I see that that will give me a new first row, and it'll have a 0 where this negative 6 is. So that's what I'm going to do in this next stage. So let's go ahead and do that. So nothing happens to the bottom row. We're not replacing that in any way. It's already perfect. Let's clean up this row. So that I'm going to take that and multiply through by half. So that'll put a 1 here, a 0 here, and a 2 here. And that's very nice. I'll talk about that in a minute. And now if I look at this last step here, I take 3 times my row 2 in this step and add it to this one. That'll give me a 1. The 6 gets zeroed out. I get a 0 here, and I take 3 times this 4, that's 12, added to that negative 13, that gives me negative 1. Now, this is great. This system, I can convert it back into equations, and the equations I get are exactly the solution that I want. X equals minus 1 is this first row. The second row corresponds to the equation y equals 2, and the last one, which hasn't changed, still corresponds to z equals negative 2. So at this point, I see I have a unique solution, and I can write down the solution set very nicely as simply the set consisting of the vector minus 1, 2, minus 2. And there we have it. Gaussian elimination in all its glory.